Push-down automata is like regular automata, but they have some extra stuff to be able to recognize context-free languages. So basically the idea is that we saw that, wait, I changed my color. We saw that regular expressions were the same as finite state automata. That means that whatever I can recognize here, I can recognize here. We proved that everything that finite state automata can do, they can also context-free grammars can do. So one of you, I don't remember, show us a way of how to encode any automata as a context-free grammar. Okay? But context-free grammars, they are grammars. They look more like these expressions here. They are syntactic. Now we're going to see something that looks like finite state automata. And they are equivalent to context-free grammars. Okay, so that's the idea. And these ones are called push down automata. Okay, and there are two ways to describe them, and you can choose whatever you want you think is more intuitive. So let's start with the one in the book. So basically, the intuition is that in a push-down automaton, you have the input on an input tape. So you have like the string that you want to accept or reject here in this input tape. And then you have a head here. And this head always moves from left to right. So it always moves like this, trying to read the whole string. So it starts here and it's trying to move till here. And that head is read-only. So that means it cannot change what is written here. It cannot erase it. It can only read it. So it's read-only, okay? And apart from that, you have stack. Stack is structured like a list, but you can only push or pop elements from this stack, okay? You cannot like go and take this C. If you want to go to C, you have to pop this element, then pop this element, then pop this other element, and then you get C here. But you can only push things on the top or pop things from the top. Have you guys seen stacks before? Do you know the difference between stack and queues?
Sí.
Okay, good. So basically, the idea is that the final control is like the states that tell me what I should do. So in the final state, say, if I read this symbol, I move to the left, I move the other symbol, and so on and so forth. Now, this is the way the book presented. Another way, if you want to see it in a different presentation, is I'm gonna do it here. It's like you have a regular final state automaton, and you have state, and you move from one state to another. That's the final control. And here you say, if I read this A, I move to this state. That is the same as before. So this is a typical regular final state automaton. For push-down automata, you also have this thing that tells me if I read an A and this A is on the top of the stack, I pop this A and then I push B1 till Bn. Okay, Bn first, then Bn minus 1. So the first symbol on the stack after this will be B1. Okay, so basically the difference is the following. A push down automaton is like an automaton, but you have this stack here. And with this stack, this is telling me if I read an A and this A is on top of the string like this, then I remove this A, I pop it, and I push this onto the stack. So it will be Bn so at the end my stack will be like this. Did you understand this intuition or not? Isabella, did you get it?
Can you repeat it, please?
But from where exactly?
From the stack that you draw it.
Okay, so basically you're saying that normally you say if I see an A, I move from this state to this state, right? From S to T. Here, apart from that, you're gonna make this move only if there is an A on top of the stack here. So here, suppose I'm reading an A. So, and this is on top of the stack, it's telling me, okay, move from S to T, read the A that you are reading, but also pop A and push B1 till Bn. So I will basically pop the A and push all these B's on top. So Bn till B1. Do you understand me now, Isabella?
Sí, profe, gracias.
So yeah, so basically the idea is you have an extra place for memory. You can remember things within the stack. Before that was the problem. So what's the typical language that was not regular? Was AN, BN, right? And I don't remember, I think it was Juan Camilo who has this intuition that you cannot have a final state automaton for AN, BN because you couldn't remember how many A's you have read because the number of A's needs to be the same as the number of B's. But now you have a stack. So that's the basic idea.
Profe, una pregunta.
Mhm.
O sea, es que no sé si me quedó claro, pero en sí como la expresión es, si leo, entonces leo un carácter, entonces si ese carácter, o sea, coma, lo que hay ahí lo comparo con el tope de la pila. Si son iguales, entonces coloca en la pila lo que está después del slash.
Well, this is just intuition, but basically it's like if I make this transition, before you will make this transition, you find an A, right? Like, let's make it simple. Let's go to this case. So basically you will say, you will move from this state S to this T. Only you find one, right? If there is a number one, you move from here to here. If there is another one, you move to here, and so on. You remember that, Angelo, right?
Sí.
Now with automata, you will have extra condition, which says like you move from here to here depending on the character you're reading, this one in this case, and what you specify here the top of the stack is. So, and if there is if the symbol A is on top of the stack, do A and pop A and push something. Then you basically you can use this stack to remember things. This is the stack.
Profe, o sea, las condiciones que se agregan después de la coma son las que me dan el manejo de la pila.
Exactly. So exactly. And another notation that might be simpler is like you replace A with B1 till Bn. Okay. So if A is on top, you remove this A and you replace that A with Bn minus 1 till B1. Okay. And
Profe,
then
en
you
en el caso que A no esté en el top, entonces no hace nada.
exactly. Exactly. That's the point. Now, what happens if you want to make a transition regardless of whatever is on the top? Then you can say, I don't care what's on the top. And then you use this notation. I don't care whatever is on top of this on the stack. And I don't care what to push. So epsilon, epsilon. That's the way to say you don't care. You don't touch. You don't want to regard the stack. Okay. Now, with this extra power, what would you? So basically, now imagine that because of this new, let's say, material that you have here, the stack and the thing, you need new set of symbols. So that's before you have an alphabet. In this case, will be, for example, 0, 1. And then you have something that is called the stack alphabet. Those are the symbols that you will use to push and pop on the stack. Okay. So, for example, in this case would be A, B1, Bn, or could be just two. Could be, for example, A's and B's. And normally it's like they are written with capital letters, like AB. And while these ones would be numbers or small letters. Okay. Now, and there is also a special symbol for the stack, which is called, sometimes it's needed, and it's called the initial symbol of the stack. And that means that every stack starts with this symbol at the bottom. Okay. Again, this is just intuition, so you get the ideas. But with this intuition, you might be able to see that there is some power, extra power. So how would you do? And now I'm going to replace these. Suppose my alphabet is not zeros and ones, but A's and B's. And whatever you can put or push from the stack is A, B, and this symbol. Now the question is, how would you use all this power to do A and Bn now?
Cada vez que me encuentro una A, saco una B, ¿no? Y así habría como un tipo de equivalencia en la cantidad de A's y B's que hay.
Yes,
O
improve on
mejor,
that
cada vez que
idea.
encuentre una B, saca una A, por lo que primero guardo las A en la pila.
Yeah, that's one part of the thing, but you're forgetting when to push things. You also need to push. I mean, the stack starts empty, In the beginning, the
Sí,
stack.
por eso no se podría, cada vez que encuentre una A, meterla en la pila, y cada vez que encuentre una B, sacar una A de la pila.
Exactly. Good job. So what Angelo suggested was the following. If I find an A, then, then what he does is he says, I don't care what's on the top, I put an A on top. I push an A onto the stack, right? So basically start reading says, and then, but you need to complete the diagram. What else do you do? Can you draw the states?
Profe, la otra sería cada vez que encuentre una B.
So, okay, so you do this, right? And every time that you find a B, what you do?
Y hay una A en el tope, entonces mete vacío, me imagino que esa es la forma de quitarlo.
Yes, exactly, that's the way. You pop it, but you don't push anything. This is take A from the stack and put nothing back. Okay, and then there is a little problem here now. One question. Okay, first of all, maybe I need to mention when you so you accept a string when you read the whole string, and there are two ways to say. One is that you end up in a final state like before. That's one way. And another equivalent way is to say that you accept when you have read the whole string and your stack becomes empty. Okay, so you can use either definition. It's the same. Okay, one question. What's the language of this automaton then?
Pero solo revisaría que tengan la misma cantidad de A's que B's, ¿no?
Exactly. Very good. Very good. Excellent name. So someone who wants to draw it, think about a little bit about and try to make to redraw the automaton so that the order is taken into consideration. So, but with this example, you are getting the idea. These push-down automata are just regular automata with an extra power, the power that is given by having extra memory, that is stack.
Profe, una pregunta. Y para, digamos, como solver ese problema, ¿no se podría dibujar como otros estados?
Yeah, of course, as many. It's just like a regular tomato.
O sea, tipo, de ese va a otro estado con las A's y ese otro estado va, digamos, no sé, a otro estado que ya es el final con las B's.
Nicolas, can you open this what do we call the whiteboard?
The whiteboard, okay.
So apart from Angelo, somebody have any propositions on how to do this automaton?
I think so.
Okay, Nain, show us.
Esto creo que sigue bugueado. No sé si ustedes leen.
But it's so strange. In the other classes, we don't have that problem. So maybe it's your computer or something. What if somebody else tries? Naim, you know how to open a whiteboard?
Not really. I can try.
But somebody else knows? You just to try from a different...
¿Tenemos derechos para hacer eso, Nico?
Creo que sí.
And maybe that's the problem. I'm gonna try to do it myself. I'm trying to share myself to see. No, you get this black screen, right?
Yeah.
That's very strange. I think that we are using it in the programación funcional, Nicolas, and it works. Try to see what could be the problem. So maybe Naim, you have other editor like Microsoft, whatever drawing tool, so you can share your screen.
I mean, Paint.
Yeah, Paint is perfect. Or a piece of paper, and you can just put the camera point and whatever works.
S- does it have to be deterministic?
No, but that's another good question. And you can also use thought. Yeah, exactly.
Um, ¿Así se escribía? No.
The first part is okay. No, but
Are you rated?
I think the first part you mean you are pushing and popping an A and you push nothing, right? I know, sorry. You don't care what is on top and you just push an A. And in the other one, I mean, in one part you are just pushing A's, and in the other one you are just popping A's. I mean, I'm following Angelo's idea.
Yeah. And
Yeah, that epsilon. Oh, that was a nice epsilon.
and here, like this.
Yes, epsilon, epsilon. Very good.
Okay.
And wait. In that part, you should only pop. Because what you just did there, it sounds like you pop the A and you put it back. You're popping and pushing back.
Yes. Okay, yeah. Okay.
Yeah. Perfect. Okay, this is perfect. And one question. Not to you, but some other person. Oops. Francisco. Francisco Suarez.
Sí.
So, can you explain Naim's solution for ANBN?
No, bro, la verdad, no creo que pueda.
Why? You don't understand what he did, or you were not paying attention?
Sí, la segunda.
Okay. So, Jorge Figueroa,
Sí,
can you please explain Naim's solution? Or
la
ask?
verdad, no, profe. O sea, con respecto al string o con respecto al stack que vimos ahorita.
Yeah, I mean, the question is why does that automaton accept ANBN?
Bueno, pues como tenemos en el primer estado, el estado inicial, que también es un estado de aceptación, podemos tener las As que queramos y 0 inclusive. Y como es un estado de aceptación, pues podemos tener una cadena compuesta enteramente de As. Y pues ese sería el caso donde el B, o sea, la cantidad de Bs que querramos hacer sea igual a 0. Profe, una duda, ¿la cadena original era ANBN?
Yes.
Uy. Entonces no estoy seguro si es correcta la
I think, yeah. So
solución.
actually, Jorge, you asked a very good question. The acceptance here is by empty. You only
Sí,
accept.
no.
You
Creo
only
que no es
accept.
correcto.
No, but you only accept if your stack is empty.
Ujú.
So under your example, the stack is not going to be empty because we have a lot of capital A's in it.
Ujú.
So, I mean, the solution is correct, but I mean, you accept only if the stack is empty.
It's
at the
empty.
end.
Okay, okay.
So can you explain now the rest? Yeah, it's good to raise this final state because are confusing. Thanks,
Profe,
Naim.
una pregunta.
Uh-huh.
Pero, o sea, como por defecto uno dice que solo es aceptado cuando el stack es vacío o uno cómo lo expresa.
Yeah, exactly. So we're gonna see this normally, formally, and you say there are two criteria for for acceptance. Either you go for empty stack and you say like a string is accepted if the stack at the end is empty, or then you don't care about the stack and you care about entering a final state, like for final state automaton. And then in that case, then this solution will not be good. Then Figueroa will be right. But I'm assuming right now here just empty stack as a notion for acceptance. Does that answer your question, Angelo?
Pues, profe, según lo que entendí, hay como entonces dos caminos para decir que el string es aceptado.
Mm-hmm.
Uno, que es cuando la pila está vacía,
Mm-hmm.
y el otro, pues la verdad el otro no me quedó muy claro. ¿Me lo podría repetir, profe?
The other one is just the standard way for regular final state
Ah,
automaton.
ok, la normal.
Yeah,
Pero
exactly.
entonces, ¿yo tengo que usar uno de los dos?
No, one or the other, not both at the same time. No, good question. You either say my notion of acceptance is going to be this one and not the other, or the other but not this one. They are mutually exclusive. Okay, is that clear, Angelo?
Sí, profe.
Okay, so well, Naim, can you explain your solution for the rest, in case some people.
Ok, so pues tenemos un estado aquí donde cada vez que lea vuelve al mismo y pues no importa lo que haya en la pila, le pone as, entonces lo empieza a llenar de as y luego hay una transición pues, epsilon, entonces pues eso me asegura de que solo haya leído as y luego pasa y ahora va a revisar que haya la misma cantidad de Bs, entonces cuando mira no sé, esto se llama el pic, creo. Bueno, sí, cuando lee lo de arriba, si es una A, pues empieza a sacar As. Entonces, si hay la misma cantidad de Bs, cuando saque todas las As, pues a la final debería quedar una pila vacía. Sí.
One question that it might occur to you is what happens, Naim, if you have more B's than A's? If you have more B's than A's, yeah. So what would happen?
It would read, pues leería el vacío y Y luego no sé, uno cómo describiría que, no sé,
No,
que
no,
sí.
no, it's good. Oh, by the way, just to improve a little bit, the B over there is a small b in
Ah, yeah.
the second state.
Yes, 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 yes.
So let's gonna run some examples here. Write A, B, B. No, but in small letters. Yeah, so let's pretend to see how this will work. So you first read the first A, and then put a, yeah, you wanna, there is some, okay. You read one A, yeah, very good. And you push a capital A, a capital one onto the stack. Yeah.
Okay.
And now you move and you read the next symbol on the string, it's the second small a. Yeah. And then you stay in the first state and then put. Then you do an epsilon transition. And then you read a B and you wonder, is A on top of the stack? Yes. So just push it. So you take it out. Then read again. And then you say there is a B. Yes, you are reading a second B. Is A on top of the stack? Yes, push it. And then empty string, and we are done. Okay, now what will happen if we have three B's? So A, B, B, B. So in that case, we're gonna, well, of course, we do the same as before. But then for the last B, we will be reading a B, sorry. And then we were wondering if A is on top of the stack, but A is not on top of the stack. There is nothing on top of the stack. Actually, there is this symbol that I forgot to tell you, the bottom symbol, but it doesn't matter, but it's not A, yeah. A is not there. So you cannot continue, you cannot consume, you cannot move to the next state. So you never get to actually read that B. So you never get to read the whole string. And therefore you cannot accept that string. Is that clear?
Profe, ¿y yo puedo decir que si le digamos el botón que digamos ponga una B o simplemente acaba al no saber cómo?
Profe, ¿puede repetirlo? ¿Qué pena?
Yes, you can play with that symbol, but it doesn't really help. Okay. Juan Camilo, you have a question?
Que si podía repetirlo, profe, como, o sea, ¿por qué no funcionaba?
Ah, okay. Naim, can you do it? Why with 3Bs your solution rightly does not accept that string?
Sí, porque pues como el anterior, lee las dos A's, agrega las dos A's, lee las dos B's, las quita, pero luego al final lee una string y mira que el stack ya está vacío y ahí es donde yo también me perdí, no sé qué es lo que...
Okay. So we are on the, okay. I explained that. You are in the last B, right? In the last B, you say, I'm reading a B. Yes, I'm reading a B. You are coming from the state T, and you see a B. But it's not only asking you about the symbol you're reading, it's also asking you something about the stack. And that question is A on top of the stack? So,
Ya.
so Naim, is A on top of the stack? It's not. There is no A. So then that transition cannot be made. And if you cannot make a transition, then you cannot read actually the symbol. So you are stuck there, basically.
Sí.
So,
Profe,
mhm.
otra cosa, ¿cómo es que definimos cuándo paraba? O sea, porque no hay estados de aceptación, ¿no?
Okay, so those are the two things. So either you say I accept when I have read the whole string and the the stack is empty. That's one. We can work with that always if you want. The other possibility is if, okay, I don't care if the stack is empty or not. I care about going into a final state. So I only accept if I at the end I'm in the final state. These two things are actually equivalent. Do you imagine why? Can you imagine why? I'll tell you one part. So it's easy. If you are in a final state, you can just start popping all the symbols from the stack till it becomes empty. You see what I mean? Then you, yeah, once you
Yes.
get to a final state, you just remove the things. And the other direction, you can do something similar too. So it's not that important whether you accept or not. But it helps to say, okay, I'm gonna accept whenever my stack is empty and I have read the whole string.
Profe, y como ejemplo podríamos hacer este problema, pero con estados de aceptación, a ver cómo queda.
Yeah, that's a good question. How you do it? This was actually the homework. How would you do it with the final state? So with final state, you don't care about the stack.
Profe, estoy un poquito perdido. ¿Cuál
Profe,
es la
¿no
pregunta?
sería,
Can you repeat the question? Some people, yes.
pues la pregunta es cómo modificaríamos ese para que sea con estados de aceptación y no con la condición de la pila de que esté vacía? O sea, porque ahí no hay como bolitas con la bolita en medio, ¿sí me entiendes?
¿No se podría hacer que colocara T como estado final y de la T sacar otro estado que sea un estado, digamos, un estado X, en donde si en T lee una A, se va para ese estado X que es no terminal y ya, pues ahí...
But
Pero creo que está
what
mal porque
condition?
podría leer una B y terminar.
But you need to put some conditions on the transition. What will be the condition of the transition to X? Why don't you? Well, okay, let's try your solution first and see if it works. Juan Camilo, remember that you have. I give you a hint, or remember that you have this initial state, initial stack symbol, that bottom symbol there.
Sí, profe, yo creo que sería, o sea, desde T, cuando encuentre una B y como que sea el final de la pila, que pase a un estado ya de aceptación, algo así.
Exactly.
Aunque
Como,
no sé, creo que no funciona por la última B, no sé.
Pero en ese caso no tendría,
Can be n, but you are getting closer. I'm sure that you can solve it. Why you do that?
¿qué pasa si uno popea esto?
no sería más bien con una transición epsilon a la X. De pronto sí,
Ajá.
sí funcionaría.
Sí, con la transición epsilon y que pregunte si en el top está Buron
Wow.
y
You
mete
suggested that?
epsilon.
Nice. That's a good suggestion. Are you happy with that, Juan Carlos? Juan Camilo,
Juan
sorry.
Camilo. Sí, profe, sí, sí, estaba pensando algo así también.
Okay. So you see, so there are various ways. So whenever I give you an exercise, you can decide which one I mean, you need to specify, I'm accepting by final state or I'm accepting by empty stack. But that's the idea, and I'm glad that you seem to have gotten the intuition about that.
Profe,
Yeah.
una pregunta, pero en esos casos no sería como siempre muy redundante, porque, o sea, la condición de que llegue al final de la pila y llegue al final de la cadena no es suficiente, o sea, porque, digamos, si yo hago un autómata con esa condición, pues siempre va a poder hacer uno haciendo esa transición epsilon con vacío, ¿no?
Yeah, that's true. But then you just it's because sometimes it's easier you say I'm gonna care. I mean, they're equivalent. They're equivalent. Whenever you can do that, you can do the other. So, and this is like the trick, but sometimes you might not need to do that for other languages. I mean, this is just for this example. So, but they are equivalent. So if you feel that the empty stack is nicer, you use the empty stack. No problem. Okay. So now we're gonna I'm just gonna give you the definitions of the thing that you just discovered intuitively. I'm very glad that you got this very well. So share content. So can you see my screen now?
Sí, profe.
So basically a push down automata is a 7-tuple. You have the states, you have the input alphabet, the stack alphabet, a transition relation, who tells me how do I go from one state into another by looking at the string I'm reading and at the stack, okay? You have the initial state, the initial stack symbol, and a set of final states. Some of the, I mean, this will be redundant if you are using final stack. So the transition relation, what we just discussed there, is basically like this. So we have pairs like this. And this is telling me just the following. You will move from state P to state Q. When you read an A and a capital A is on top of the stack, then you will push all these symbols onto the stack, on the top of the stack. First this, then this, then this, then this, then this. This will be the last one that you push. So that means that B1 will be on top because it's the last one being pushed onto the stack. So again, intuition helps. This thing here in the picture will look something like this. You have P, you're going to Q, you are in an A, and A needs to be on top of the stack, and then you push B1, BK, meaning that it's important. BK first, then BK minus 1. B1 is the last one being pushed. That's one possibility. The other possibility that you already used was this one. Can somebody tell me what this one is telling me? It's similar to the other one, but I guess maybe you get the idea. What do you think that one is telling me? This transition. Anyone?
Profe, ¿puede repetir la pregunta?
I gave you the intuition about this one, right? You are moving from P to Q. You are in an A, and capital A is on top of the stack. So what do you think this one is telling me?
Es una transición epsilon.
Exactly. That's it. You just set epsilon transition, and you are just popping A and pushing B1, BK. And then there is this other one, because this K could be 0, then you can say I can read A if A is on top of the stack and I push nothing. Or I can even have this one. Right? Oh, this one that somebody already used. I just go from P to Q. Okay. Then we can define the notion of configuration, if you want. So what's a configuration of this machine? This is the machine representation that they use in the book. This is the state that you are at any point, the string that you are reading, and your stack. So basically a configuration is a snapshot of the machine. So it tells me the current state you are at, the string that you still need to read, which is, in this case, is here, so it will be, I'm here, I have read this, I still need to read these 3 A's, 2 B's, and an A. So B, 3 A's, 2 B's, and an A. And this telling me what's on the stack is, this is the bottom symbol, then C, A, B, and this capital A is on top of the stack. So this is a configuration, a snapshot of the automaton. So the stack configuration will be this one, right? If the string that you want to accept or reject is X, your initial configuration will be S, which S is the initial state. You still have to read the whole string X, and the stack only contains this symbol and nothing else. Okay? And then you define a notion of transition. You say how you move from one state, one configuration to the next one. So this is element. Suppose this one here, sorry. Suppose that you are state P, A, you are reading A, and A is on top of the stack. You need to know what's the next, and you are saying my next state is going to be some Q and some gamma. What's gamma and what's Q? So here is the move, the corresponding move. So this is one of the transitions, right? So this is the one that, if we draw this, basically, remember this intuition that we had before, P, Q, A, gamma. So, and then we go back to the idea of this snapshot. So the machine is in this configuration. So the current state is P. I need to read A, Y. So the string that I'm reading right now is A. And I have stack whose first symbol is A, and then there is B under it. So the stack in this configuration would be like something like this, A, and some beta string below. So what's going to happen here is in one step, I move to Q, because that's what it's telling me, that I need to move to Q. I move to the rest of the string. So I have read A, so I can move to read the rest, which is Y. I pop A from the stack, and I push gamma onto the stack. So my new stack is going to be gamma beta. Is that clear? Sometimes it's harder to explain the mathematics than the intuition. The intuition, you all got it immediately. But in order to prove things formally, you really need the mathematical definition. The intuition is not enough, as I showed you before. So, sorry, somebody was saying something? Is this part clear with how I move from one configuration to another?
¿La M qué significa?
M is just the automaton. So is the given is the transition on this automaton. Okay. And just to mention, this is for this automaton. So basically, it's telling me how I move from one configuration to another. So imagine that I move from here to here and pop in this. So it's basically saying that I move from that configuration before to this new configuration. And how do I go there? By using some of the rules, maybe a rule that told me that whenever I had B and A on top of the stack, I should just pop the A, and then it will move to the next one. Okay? Is that clear, Naim?
Yeah.
All right, so this is just, remember, configuration snapshot. I mean, you know the meaning of snapshot, right? Snapshot is like, if I look at in some instance of time, I look at the machine and I can see that it's pointing at B, I'm reading B, I can see the stack, and I can also see what remains to be read. That's all. So now I need to know how these configurations evolve. So the same rule for the epsilon case, I'm not going to explain because it's very similar. And then the other things is very simple. I define the transition configuration from one configuration to another. Basically the transitive closure of the relation of this relation here. Meaning, I think we saw something similar before. C moves to C in 0 steps. C moves to a configuration D in n plus 1 steps if you move to some E in n steps, and then from E to this D in 1 additional step. So the number of steps is n plus 1. And you move from C to D in 0 or more steps if there exists an n greater or equal than 0 such that C goes to D in n steps. Once I have defined that, I can define, okay, I want you to define that one yourself. So I'm going to give you one of the two definitions. I'm going to explain this for you, and you're going to be asked the other one. The machine M, the automaton M, accepts X by final state if you start from the initial state reading X with only bottom the stack, that is from the initial configuration, you go in 0 or more steps to some state Q. You have read the whole string, so there is nothing more to read. And I don't care, there is some gamma at the end of the stack, but you accept it, this Q is a final state. So basically you go from the initial one to some final state Q after having read the whole string. So there is nothing more to read. And basically this one, I don't care. It's just a 0 or more symbols in the stack. So that's the final state one. How you define the accepted by empty stack?
Pues, profe, sería que desde el estado inicial, con la transición de asterisco, vamos a llegar a un estado donde sea Q, epsilon, button, donde no nos importa qué es Q.
Yeah.
Pues, sí.
That's exactly what you say. So you start from S, X, here, the initial configuration, and you end up in some state, I don't care what Q is, as you said, but I have read the whole string, and my stack is empty. Okay? I know that you said something a little bit different, but that doesn't really change much. I mean, your answer was correct, Angela. You can put this in here, and that will be good enough. Okay, so now we have defined formally what we described before intuitively. Is that clear, the formal definition for everyone? Okay, so, and then once we have defined that, we can define what the language of an automaton is. The language of M is the set of all strings that are accepted by the machine. So the set of all X such that you start with initial configuration with X, you end up in some Q that is a final state or some stack that is empty, depending on which one you want. Okay, so next time we'll see more examples and we'll see why is that these things are equivalent to context-free grammars. And that will be the end of this second part of the exam. Switch to Spanish. ¿Alguna pregunta? ¿Todo queda claro?
Aparentemente sí, profe.
Aparentemente, bueno. Nicolás, ¿algo que agregar?
Sí, dos cosas. Está pendiente una exposición, ¿no?
Ah, bueno. Bueno. Muy bien, gracias.
Y estaba revisando los PDFs, ¿cierto? Y esta parte no está. Entonces no sé si
no está,
si
yo pensé que te
me
la
la
había
puedas
enviado.
mandar.
Ah, voy a mirar. De pronto me equivoqué, pensé que te la había enviado. Bueno, gracias. Después recordarles. Muchachos, ¿alguna otra pregunta? Bueno, entonces que tengan un buen fin de semana y que estén muy bien, muchachos. Hasta luego.
Frank,
Todos. ¿Sí?
La exposición para cuándo queda entonces, más o menos.
La exposición, ¿quién la está dando?
A Francisco Suárez.
Francisco, ¿cuándo estás preparado para la exposición?
Yo ya estoy preparado desde hace como una semana.
Bueno, entonces la podemos hacer este lunes. No hay problema.
Listo.
Bueno, ¿me recuerdas, Nicolás, entonces? ¿Listo?
Listo, Frank.
Bueno, esté muy bien, muchachos. Hasta luego.
Hasta luego.